Well, good morning, everyone. I'm Joe Rensis, the Dean of Engineering at Cal Poly Pomona, and we appreciate you taking the time to learn a little bit more about our this graduate program information session. First thing I like to do is to first congratulate our graduates. What a special time in your life in the beginning of a lifelong journey. And if you're not graduating, that's all right too. You're just one step closer to graduating. Next slide. You know, I thought I would start off with this thought for you, a quote by Alan Toffer. And the quote really talks about literate and illiterate in particular. And it really says here, the illiterate of the 21st century will not be those who cannot read and write, but those who cannot learn, unlearn, and relearn. Again, learn, unlearn, relearn. And so I think one thing that graduate education does, it provides you this perspective to learn, but to also start to look at things at another perspective and to unlearn and then to relearn things. And to solve future challenges of the world, we're going to need to know how to do more of learning, unlearning, and relearning. Next slide. So our schedule today is going to be from 10 to 11. And what I'll be doing is giving you a broad overview about going to graduate school. And then we're also going to have an opportunity quickly to visit with the different departments. We have 7 of them, and kind of learn briefly about their programs. And then from 11 to 12, we're going to have some breakout sessions. One session will be on some campus resources, which is financial and graduate studies. And then separate from that, you will see each department. If you have an interest in a particular department, you'll be able to visit them. And we will give you those links a little bit later. Next slide. So what I'm going to be doing today is giving you an overview about the graduate program, and a little bit you're going to hear from our departments about their program, just to give you some basic facts and recommendations here. Not necessarily a formula of success in going to grad school, but to give you some guidelines. Next slide. Now, some of you probably are just graduating, and you're probably going to go off to work, as you can see down here on the bottom. Maybe someone will be going directly into graduate school. But even if you're going into work, if you want to really progress in your job, you're going to probably need to go on to graduate school. So you'll probably be doing that in parallel. Or you may go out to work and you decide you want to go full-time to graduate school. So we're going to talk about why go to graduate school. So next slide, please. So there's a number, you'll see with the slides, I have a number of items there. I'm not going to go into every single one in depth, but like as the first one says here, it's necessary for your desired professional field. For example, if you want to become a lawyer or doctor, you're going to have to go to graduate school. Or if you want to really improve your career or learn more depth in a particular area and become the expert, you're going to also need to go to graduate school. And it also could be is that you want to be really the leader and to have a big impact, and that would be some other reasons to go to graduate school. Next slide, please. Now, what we see here is really medium weekly earnings, and this is for all fields. But if you look down at the bottom, you're going to see if you have a less than a high school diploma, how much you're going to make on a weekly basis. And as you increase your education, you can see here you make more per week. This also correlates to income over a lifetime. So going to graduate school, you'll see not only an increase in weekly earnings, but overall also in a lifetime. Next slide. This also gives you a sense of being unemployed. So if you have less than high school and then you proceed up vertically, you're going to see that being unemployed is going to decrease with a higher level of education on average compared to having a lower degree. Next slide, please. So another thing to think about is why not to go to graduate school. One thing I do is point you to the bottom here, where it talks a little bit about grad school is a big investment. And that's something you need to really think about. It is a big investment, not only in time and effort, but also money. You shouldn't necessarily be going to graduate school because you don't know what you want to do. Again, because it's a big type of investment. You need to really kind of think about your career and how it's going to impact your career progression overall. So I'll go to the next slide here. So when's the right time to go to graduate school? And a lot of it really comes down to when you know you can be a successful graduate student. You might be thinking, as an undergraduate, I struggled a lot. And that might have been the case, but that doesn't mean that you cannot go to graduate school. You're never too old or too young to go to graduate school. However, if you struggled as an undergraduate, it is important for you to spend some time to really determine where your particular career is going. Right time to go. Individuals that go are effective planners. They have a lot of initiative. They have also a high level of maturity. Individuals that can really take disappointment because it is a challenge going to graduate school. And also, really, there's a marathon as you go through graduate school from the beginning to the end. Next slide. So what's the difference between graduate school and being an undergraduate? Well, one thing you need to realize, you do have to have a bachelor's degree to go into graduate school. But there's this misconception that as an undergraduate, that's similar to being a graduate student, and that is not the case. What you're going to find is that graduate school is more competitive, and really there are fewer slots there. Students, they don't actually change their majors like they did as an undergraduate. There's not any opportunities really to explore different avenues while you're in graduate school. Graduate school tends to be more focused and specialized than the undergraduate degree. You go into a much deeper dive into a particular topic. And people tend to be very passionate about what they're pursuing when they're in graduate school. Next slide. If you're a graduate student, you're going to find that your classes tend to be smaller. You're not going to see large lectures. As a student, I had been in a class size of about 5, typically 10 to 15. Sometimes they can get large depending on the topic, and they could go between 30 to 40. But typically they're very small in nature. They tend to be much more intense than the undergraduate. You're also not necessarily given much homework or fewer quizzes or fewer exams. You are expected to really be self-directed and very motivated to be able to learn the topic. And one thing you're going to see here on the bottom is students typically in graduate school are very much engaged in research, which we will talk about, and that's outside the classroom. Next slide. So how do we choose between going for a master's or doctorate? So typically in engineering, you start out with a master's, and if you're interested in a PhD, you typically need that. Sometimes there's a direct going into the PhD, but masters, they tend to be very, very specialized in the field. And it ends up, some of the master's degrees are terminal in a particular field. So if you happen to be in the area of architecture, that happens to be a terminal degree. Business, you'll see your Master of Business Administration is a terminal type of degree. PhDs, they take a lot longer to get. They prepare you, for example, if you want to go into an academic career. So as myself, you want to work in a particular research lab doing really state-of-the-art type of research. You go into that and into business and industry. Next slide. So what this slide does is it kind of gives you a contrast of what things look like if you're an engineering student as an undergrad versus being a graduate student either at the master's or PhD level. So one thing you're going to see as an undergrad, it takes, if everything goes along and you're on the proper sequence, it takes 4 years. With a master's degree, it can take 1 to 2 years full time. Again, that really depends on the institution that you do go at. Typically, it tends more towards 2 years. You tend to take a lot more credits as an undergraduate. You see there 15 to 16 hours per semester. Whereas a graduate student, you will typically take coursework of 6 to 9 semester hours per semester. As an undergraduate, you tend to take a broad range of type of courses, not only in gen eds, you take them in engineering, math, and the science. At the graduate level, you tend to be more specialized, particularly taking courses related to your specialty. So you'll see a lot of engineering, math, could be science, and other technical courses. As an undergrad, you typically have a lot of labs, which at times you can as a graduate student, depending on the particular area you're in. And as an undergrad, you do a lot of projects, and a lot of times they're industry-based. But as a graduate student at the master's and doctorate level, it's very common to do original type of research or a thesis, which we'll talk about a little bit more later on. Next slide, please. So this kind of gives you a contrast of how many units are associated with being a master's student as opposed to a PhD. Typically, there are two routes at the master's level. One is a Master of Science in, for example, engineering with a thesis, and then one with a non-thesis. You'll notice both of those are actually equal to 30 semester hours. Some schools will vary and have a little bit more. The MS with a thesis is typically about 24 semester hours of coursework and 6 semester hours of research. But I've actually seen the thesis be actually up to 12 hours with a less emphasis on coursework, but in general it's 24/6. Non-thesis is a little bit different. There's a little bit more emphasis placed on the courses, and instead of doing thesis or research, you typically are working on some type of project. And a lot of times it can be related to what you're working on in industry. Now, the doctorate requires a much bigger commitment. Typically in engineering, you have a master's going into PhD, though it's been more common in recent years to have a direct admission to PhD. If you happen to go and decide you want to be a scientist, typically in science, you do a direct route into the PhD. But the PhD in engineering typically has about 24 hours associated with coursework, 24 hours associated with research. Some schools I've actually seen where the coursework will be a lot less, or sometimes not even exist in some places, and the research will be larger. Next slide. So what is this thesis? I'm not going to read through all these things here, but at a real high level, what you might think about is when you're in school and you're going through your books, you're learning a lot of knowledge. And at times you're learning a lot of depth in the knowledge. Well, what a thesis is you're creating new knowledge in a particular type of an area. Some might be a little bit more easier to create that new knowledge. If you're in a brand new field, there happens to not be very much knowledge, you can have a quick impact. If you happen to be in an area where there happens to have been a lot of work done in the past, when you do your literature review, there it will take a little bit more challenging times to find original topics to progress the state of the art and the state of practice. Next slide. Now, if you end up deciding to go full-time as opposed to part-time, typically part-time you come in, take classes, and leave. As a graduate student, it's a little bit different than the undergrad. As an undergrad, you're typically all around campus. You're in different buildings, where when you go to graduate school, typically you're in one area or one building on campus. And a lot of times when you're pursuing a certain degree in a department, you're spending all your time there. What you'll find when you're doing your master's and PhD is your faculty advisor is a big important part. Typically full-time, you're focusing on doing your research as your main outcome, even as a master's, but more importantly as a PhD, depending on your advisor. And your advisor may allow you to be able to travel and attend conferences to see what's going on in the area, present the work that you're doing, potentially publishing that research at conferences, and publishing in the journals related to that area, and potentially maybe having a patent. But all this will vary depending on the particular advisor that you select to carry out your thesis work. Next slide. So what's the typical application process? This is a very high level. You need to go out and look at your application. Most applications today are online. We use Cal State Apply. One thing that's a little different between applying for bachelor's as opposed to going to graduate school, typically you apply to the graduate school, or you apply to the department, and the people that evaluate your application are actually the faculty, the individuals that work in that area, as opposed to an admissions office. If you're looking to go to graduate school in engineering, the expectation is that you have your Bachelor of Science from an ABET accredited institution. All your degrees here at Cal Poly Pomona are ABET accredited. Official transcripts are another important aspect, even if you've taken one course or you've transferred in from a community college. Reference letters, typically around 2 to 3. We'll talk about what they look like and how to get good ones. And also a statement of interest. I'll talk a little bit more about what that is, but that will depend on the particular department. Next slide. A GPA is going to be another important piece. Typically for full admission, it's about 3.0. I've seen it as low as 2.9. It varies with the institutions. You might think, well, I happen to have a lower GPA. And lower GPA, it is very possible to be able to go to graduate school. People do it. And what they do is they get provisional admission, they prove themselves, and then they're admitted to full standings. Some institutions will require you to submit standardized tests. As an undergrad, you're taking the SAT and the ACT. If you're going into engineering, GREs are the very popular one to use. If you go into business, the GMAT. These may be required or they may not. Application deadline for us this year is July 1st, 2020 for all the programs. Typically, if you're looking at ahead and planning on going to graduate school, they have different admission dates. Some places will require your application for the fall be in as early as December. Some will be January, February, and others will be rolling. Next slide, please. So I kind of want to give you a sequence here. If you happen to be a junior at this point, this will kind of give you a sequence between now and when you graduate. If you're a senior, then you can look at this as under a very compressed schedule if you just graduated. So typically the way to start and to look to your future, if you're planning on going to graduate school, let's say after you get the undergrad, either full-time or part-time, you need to look at your interests. It's important that you talk to faculty to get some career ideas. They know a lot about the programs around the country that are in your particular area, and a lot of times the research you're doing. It's strongly recommended to differentiate yourself beyond your grades, beyond actually your test scores, is to actually do some independent research if you're particularly looking at going full-time. You'll see the second to the bottom. There are various summer research experience for undergraduates around the country. For example, myself, I've had 5 of these sites and had students through over about a 15-year period doing these type of things. And if you're thinking about going to graduate school, think about maybe visiting some. That can be a very important thing to help you get financial support. Next slide. The summer, it's a good time to start studying for that particular standardized test and take the exam. Start researching the schools, writing a personal statement, which I'll talk about. Potentially, if you live somewhere else, you could visit some campuses. Typically, though, in the summer, there's not as much activity, so it's very important to plan that very carefully. And if you're very fortunate to be able to get a summer research internship like from NSF, you could participate in one of these. That would, again, strengthen your application. Next slide. The fall of your senior year, start to get in there and get all the applications, do those visits, maybe continue to prepare and increase the scores that you get on your standardized tests. It's important to take the exams before the end of October, because especially if you're going to be applying in December and January, you need to have them completed. Work with your faculty too to make sure that these places will be a good fit and they'll be of your particular interest. And also contact people, especially by the end of November, to write references. And you may have to do this actually earlier if the deadline is in December. Next slide. And when we get to the spring, you're completing your applications, doing visits, and you're waiting to be able to hear for those particular type of offers. Go to the next slide here. So one of the things I thought I'd talk about a little bit are these personal statements. The reason I'm talking about these, a lot of times people don't know what to expect in these things or how do I write them. Some graduate programs require them, some do not. How they use them can have wide variation. For example, if you're just looking for admissions, even if personal statement is required, it may not be looked at very much, but if they're going to offer you like full support to go to school, they will look at it very seriously. And that's something you don't necessarily know as being an applicant. But as you can see here, try to answer these questions at the bottom. Why are you applying to it? What are your short-term and long-term goals, etc.? These things can be very, very important in determining admission and also whether or not you will get some type of financial support from the institution to go to graduate school. Next slide. Letters of recommendation. It's very important to get strong letters. I think the key I tell everyone, it's important to get individuals that really know you. You can see characteristic. Writer knows you and your work. Writer likes and respects you. Writer has relevant academic or professional credentials. Why is that important? If you're applying to a particular place and you have an interest in focusing on depth in a particular area, and that individual is known in that area, that letter could go a lot longer way from an individual who does not work in that area. Do not get letters from your fellow students, your friends, and also your relatives. Those are weak letters of recommendation. Next slide. So the key here is primary faculty are having direct knowledge of you. They want to know and they'll write about your commitment to the field. They've seen you as an undergraduate in a lot of different ways, not only courses and labs and projects. They can also comment about you personally, because at times when you go as a graduate student, you'll be working under a team and you have to work with other individuals. So they're going to want to know a lot about interpersonal things and other things. Potentially, let's say you were in a competition team, internship, research experience, those will become also valuable. That recommender can write about that. Next slide. So advice for requesting them, do at least 3 to 4 weeks before the deadline. Do not assume that the person's going to send it in right away. The faculty actually do get busy, so be sure you follow up with them. It's important to provide them different information you can see, resume, list of engineering courses, grade received, and so on. Those can be very helpful. These take a lot of time and effort to write a really strong letter. So I always appreciate it when I write that letter and someone sends me a thank you note. Some applications are still paper. I had one last year from a former student, and that individual sent me actually an envelope that was self-addressed and stamped, and people do appreciate that if that's the case. Next slide. A little bit real quickly regarding GREs. GREs are typically used in engineering. They may be required, they may not, depending on the institution. They typically are required, especially if you're going to get financial support. There's typically 4 sections: a verbal section, quantitative, analytical writing. From an engineering science point of view, the one they look at the most is the quantitative. A little bit different range than what used to SATs, 200 to 800. They used to be that way. Now they're 130 to 170. More highly competitive programs will be like 155 to 170. When I was a graduate student, I had a lot of friends that were close to the 170. Analytical writing, engineers actually do pretty well on this one. I've seen studies. A good score is about 4, 4.5. And compared to a lot of the other fields as undergrads, engineers do well here, and this could actually help you. Sometimes there are required subject tests in engineering and physics, but it depends on the institution. GPA, you get to more competitive programs, you're going to want to see a higher GPA, and also especially if they're going to support you. Sometimes, you know, you start out as an undergrad, don't do well. I remember I didn't do well initially, but later on did really, really well. And so sometimes you break up that GPA as a major or junior, senior GPA to basically show that you can be successful, hopefully, as a graduate student. Next slide. If you end up you think of going full-time, it's very important to visit and to go and meet the department, especially the graduate coordinator, because they control a lot of the admissions, and the faculty get together and decide who gets admitted, and a lot of times get financial support. Good idea to meet with current graduate students, get an idea of the culture that's going on there. And the other thing is, if you're thinking about working in a particular area, is meeting with those faculty that will potentially be your thesis advisor. And also spend time and tour the department, the lab, and the campus, and the community. Next slide. So we're almost going to be the departments here. So what makes our program unique compared to others? I think the first thing you're going to see is an industry-friendly class schedule. For example, where I did my master's and PhD, we had all our courses during the day. We end up offering our courses here in the late afternoon and evening. And we don't have as many prerequisites for our courses at times. And then in addition, we're not cohort-based where you go through with a group of individuals. You'll see we have applied learning as our major approach, and our instructors have that experience in industry. And this type of degree actually is very well respected out in industry to help you to grow and develop professionally when you're out in the company. Next slide. If you happen to be a Cal Poly Pomona student, no letter of recommendation are required, and the GRE is not required if you happen to have greater than a 3.0. Next slide, please. So this is a high level of our programs, and then we're going to have each department give a brief overview. On campus, we have all our degrees except aerospace engineering at the master's level. Off campus in Lancaster, we have the we offer the aerospace engineering, and that's open to the entire community up in the Lancaster area. This fall, we're actually going to be starting a partnership with Northrop Grumman Corporation. So if you're an employee, we'll be offering degrees for aerospace engineering, material science, and also mechanical engineering. So next slide. So now we're going to have aerospace engineering give you a quick overview.
Hello, good morning. Can we go to the next slide? I'm Naveed Nekjuri. I'm a professor at the Aerospace Engineering Department. I'm also the graduate coordinator for this program, and I'm happy to give you a very quick overview of the program that we have for this department. Can we go to the next slide? So this program started in 2007. We had a smaller graduate program before that, but this is a much higher valued program that we started in 2007. It's mostly targeting the aerospace professionals in the Lancaster area, in the Antelope Valley area. And if you're familiar with that, that's a big aerospace hub. We have companies like Northrop Grumman, Lockheed Martin, Air Force, and NASA Armstrong over there. And a lot of students that we receive are from those professional aerospace companies. That being said, this program is designed and tailored for people that they work full-time. So we offer all classes after 5 p.m. We offer 2 classes every term, 6 classes per year, including summer basically. And all of these are after 5 p.m. so students can attend after they're done with the full day of work. And we have most of the students finishing the program in 2 years. Just to make sure, this program is in Lancaster, and it's about 100 miles away from the main campus. But it's open to students to attend, not necessarily just to live in Lancaster for any other student. It's much easier if you live in Lancaster and work for one of these aerospace companies. Can we go to the next slide? For this program, we have 1 math course required, which is the numerical methods. And we have 5 aerospace core courses that are designed to give you a little bit more depth in aerospace related technical field. And we can give you an option to choose 3 aerospace technical electives based on what you are desired to get your professional degree in. And at the end, you have a master's project, which is basically a master's research, but in the envelope of a project. 2 terms of research is required, and you have to write a report and go through a community defense. So that's what is designed for this. And if you need more information about this, I will be more than happy to give you more information in the Aero session. Next slide. We don't need a lot for the admission. We only need that you have a GPA of 3 or better in upper division graduate courses, and we need your transcript. You can send your CV, that's optional, but that's all we need for the aerospace program. One last thing that I want to mention, right now this program offers a Master's of Science in Engineering with the emphasis in aerospace, but we are getting the approval to change the program into the Master's of Science in Aerospace Engineering. That's it. Thank you.
All right, next we are going to have the Department of Chemical and Materials Engineering.
Good morning, everybody. I'm Dr. Ravi. I am the department chair for chemical and materials. I'm also the graduate coordinator for our graduate programs. Next slide, please. So the graduate program in CME is the Master of Science in Engineering with an emphasis in materials engineering. And just to pick up on where Dr. Natkari left it, this will also hopefully be in the near future be changing over to Master of Science in Materials Engineering. Next slide, please. So materials science and engineering, in this case, our program is of materials engineering is a broad tent. It covers a lot of fields, and so it's open to all branches of engineering, and depending on the background, there may be a class or two that needs to be taken in preparation. But it's open to all branches of engineering, and the physical sciences students also apply from time to time. The idea here is that we try to interrelate, structure, property, processing, and performance. This is like a broad tent that allows us to work in a number of different exciting areas. Classes are offered after 5, typically begin at 5:30 or 6 o'clock, and makes it convenient for students to commute from their workplace. Of course, now we are in a Zoom mode, which is a little bit even easier. Next slide. So this is a platform currently that we are sharing along with Aero. So there's a math course that was referred to before. Here we have 5 materials engineering classes. These are the core courses ranging from thermodynamics to corrosion. And then we have 2 elective courses, and these are currently in the area of energy materials and biomaterials. And then we have a master's thesis. That's a unique feature of our program, is we have a 6-unit, 1.5-year experience in thesis. Next slide, please. We will go into this in more detail in the individual session, but basically, it's as I told you, it's a broad-based discipline. So a BS degree in engineering from an ABET accredited program, and if a GPA is above 3.3, then you can get in without the GRE and so forth. And conditional admission if you're over 2.7. If you are not meeting any of these criteria, you can still try. You can supplement your background with a good GRE score and our letters of recommendation as needed. And for this year, the GRE and TOEFL have been waived. I think that concludes my presentation. I'll see you in the Zoom room if you're interested. Thank you.
Now, next up is the Department of Civil Engineering.
Good morning. Next slide, please. I want to thank you, everyone, for joining me to learn about the Civil Engineering graduate program. I'm Lisa Wang, the graduate coordinator for Civil Engineering Department. Next slide, please. As you know, civil is a broad field with several different disciplines. So you can see our graduate program is very comprehensive with 5 different degree options. We are going to talk about each of these degree options very much in detail during our department session at 11. Next slide, please. So for the degree requirement, we are talking about for all the degree requirements, we have the common degree requirements in terms of coursework and curriculum, and we require 30 semester units, and this also includes the units you're going to get from a master project or master thesis or comprehensive exam. By the way, civil, we have this very flexible in terms of the accommodating experience requirement, so you can choose from 3 different options. I believe this is also one of the great advantages for our graduate program. So depending on your interest and strengths, so you can either choose a master project or thesis, or you can take the comprehensive exam if you're really good at coursework. So that will help you satisfy the accommodating experience requirement. And just as other graduate programs, our coursework will contain both required and elective courses. Next slide, please. Next slide, please. Can you hear me? Okay, so for the admission requirements, so we have most students that usually are admitted unconditionally. Can we go to the previous slide, please? I think we skipped one. Okay, thank you. Yeah, so for unconditional admission, we require your overall GPA is about 3.0. And also because civil, we have 5 different degree options. So we really also would like to look into the preparatory work, the coursework in the specialty. And so because we want to assure you are going to be successful and achieving your master's degree with a good preparation in the specialized field you choose. So we're going to talk about this more in the department session because this is specific depending on the degree option. Next slide, please. Okay, for conditional admission, we are going to discuss more. So we do have, different ways students, can actually make effort and if they are really committed, and we do give them the opportunity to eventually for them to be considered for our graduate admission. So we're going to talk about this more in our department session, and so just make sure you also ask us questions at that time. We have several faculty available there during our department session, and thank you all for your time and attention.
Next up is the Electrical and Computer Engineering Department.
Hello, everybody, and welcome to the event. I'm Thomas Ketchiglu, a professor in Electrical and Computer Engineering. I'll be talking about our program. Next slide, please. So we have a Master's of Science in Electrical Engineering. I would like to mainly say a few things that could help candidates towards their decision. And of course, we have this slide set here that we prepared, but my emphasis on this short talk will be on some points that are very basic to our program. Next slide, please. So the program is one of the oldest master's programs in the School of Engineering at Cal Poly Pomona. Electrical engineering is a very versatile, diverse, and in high demand field. And it offers very good career prospects in the area in Southern California. It's a high reputation program with a very good past, present, and it's well positioned for a great future. We offer state-of-the-art education in all the fields, basically, of electrical engineering. And if you go back down here, you'll see that we cover computer engineering, and you all know about artificial intelligence and big data, which is one very big area these days. And it's covered here. We have communications and signal processing in wireless communications, a lot of activities, signal processing as well. We have control and robotics, a very good popular area as well. Electronics, we cover nanotechnology, we cover microelectronics, and in power, we also cover standard power engineering plus smart grid, which is very trendy technological area. Next slide, please. To complete the degree, the requirements are quite kind of standard. We need the student to complete 30 semester units. There are nine units that need to be covered with courses that are required by all students entering the program. And then the student can emphasize more on his or her area of expertise, and this will include 15 units to be taken within that area. Of course, this is in consultation with the advisor. And then the terminal degree requirements, if you want, are either through a project that is about 3 units. It can go all the way to 5, and a thesis, if it's so selected, for a more kind of extensive study. And this will take 4 to 6 units, semester units, to complete. Next slide, please. The admission requirements are also kind of standard in the School of Engineering. The basic thing to remember, I'll talk about the details later, but for this year, as other presenters before me mentioned, GRE and TOEFL have been waived as requirements because of the current situation with the COVID-19. Next slide, please. Oopsie. And I want to close by saying that electrical engineering covers a very wide range, and in the school we try to offer classes in all these areas, as I said before. And if you are interested, please apply. Thank you.
All right, next we have the Electromechanical Engineering Technology Department.
Well, good morning, everybody. I hope you've learned a lot so far. As was introduced, thank you, Dr. Rensis. I'm Dr. Scott Boscovich from the Electromechanical Engineering Technology, and I'm going to present to you our upcoming program, which we will talk about in the next coming slides. Next slide, please. So we're going to be offering a Master of Science in Electromechanical and Mechatronics Engineering. We know that nowadays, so many things that we deal with include a chip, as well as something mechanical. And so we want to embrace that combination of the two and explore more in depth in our program. Next slide, please. So we're planning on rolling this out in the fall of 2022. If we can get it done faster, we will, but I think that's a fair time frame to look at. What we're looking at doing is really delving into the inner depths of the relationships between the electrical and the mechanical. There's 2 common domains that we see really emerging in aerospace and automotive and several other areas of engineering. So we're going to bring those 2 together. We're going to discuss the different areas of controls and go into quite in depth for the controls theories and how they apply to robotics, autonomous vehicles, autonomous systems, embedded systems, and mechanical systems. There will be 2 different emphases in the program as well. So we're going to be looking at controls, but there's going to be a lot of controls that we can be doing in the software and the electrical engineering domains, as well as the mechanical domains. And so we'll be looking at how these 2 different tracks relate to one another. So there'll be a specialization. So if you're more mechanically centric, then you may want to explore that type of area. If you're more of a software embedded designer, an electrical engineer, then you want to do more robotics, but you still want to understand the relationships to mechanical, then we can go into those areas. As you see some of the pictures, they show the robotics that we would be looking at in detail. Next slide, please. So we have a common core set of courses, and we're going to see mechatronics as a fundamental element of it, but we're going to be looking at a lot of different control strategies that include modern controls, nonlinear controls, and adaptive controls. And so those are common between both of the discipline aspects. So we'll have that as a common, but then we'll also allow 3 courses of specialization. And we'll get into that in the next slide. You also have the opportunity to do either a thesis and work with our faculty, which can include some Dr. Akbari, who's a specialist in engine design and engine control, Dr. Abedin, who is a specialist in material science and materials and deformable materials and mechanical relationships, myself as robotics and distributed autonomy, as well as Dr. Kirschnud, who is a specialist in mechanical or mechatronics engineering. So you can choose if you want to do a thesis with either any one of us, and as well as additional faculty that we'll be bringing in to help support this type of a program. Or you may opt to do a research project, and in the project what we're going to be doing is we're going to do rapid model-based design as part of the project, and you'll also explore some of the project management aspects of it, and then it's going to evolve into a project. And again, these could be areas that if you're working, could be very appropriate and applicable to what you're doing to further enhance your skill sets that your company might in fact be interested in. Next slide, please. So when we look at the curriculum specializations, in the embedded electronics specialization in controls, we're going to be looking at real-time systems. We're going to be looking at how we stick control systems into an FPGA and develop the embedded processing into the FPGA to design an embedded controller. We'll look at additional sensing mechanisms. So, for example, we have the sensor fusion, we've got Kalman filters, we will have computer vision, and how all those things relate together into a controls aspect, as well as autonomous vehicles, which are very, very popular now. We see them really emerging. So we're going to be focusing on that as well, and how they might all talk to one another in a distributed sense. On the mechanical side, we're going to be looking at different areas of the mechanics of materials, of maybe deformable materials, and how these could all work together. We'll be looking at the different aspects of dynamics and how that fits into the controllability of a given system, as well as, again, going back to some of our research of our faculty, we'll be looking at how do we design engines and the control systems therein of advanced turbo engines or car engines of those likes. The other thing I want to say is we are still developing the requirements for acceptance, because we still have till 2022. We're looking at the different opportunities of what's going to provide the greatest penetration. We're also looking at bringing in people who are maybe mechanical engineering by themselves, or electrical, or maybe you came from an electromechanical engineering background. So we're open to a lot of different areas, because we recognize that this is also a very emerging yet diverse opportunity for you guys. We've talked to many in aerospace industries and companies, automotives, and they're very excited about these opportunities that we're discussing in this program. So we're looking at basically a GPA of a 3.0 in your undergraduate. We're still working out the details of it, but I think you're going to see it's going to be pretty consistent with what you've seen so far within the College of Engineering here at Cal Poly. I'll be in the Zoom room for discussing if you have any further questions, and I look forward to seeing all of you there. Thank you.
Well, next we have industrial and manufacturing engineering.
Good morning. I guess Dr. Plasencia was supposed to start, but I'll go ahead and continue. Is Dr. Plasencia, are you available?
I'm here. I'm not sure why to take the show.
No, please go ahead.
Okay. Good morning. Next slide, please. Yes, my name is Dr. Greg Plasencia from the Industrial and Manufacturing program. You'll notice that we have two programs to offer you for many of our students. And I have to stress the fact that our program is a bit different, because often we get students from different types of programs, not just from industrial and manufacturing, but we tend to get them from across many different engineering fields. Next slide, please. So for example, we have our engineering management program. And you notice that one of the things that we stress is the fact that we want to help a lot of already people that are working in the field be able to increase their knowledge, particularly to be highly qualified engineering managers. And so we have a very multidisciplinary program, and you'll notice that when we do talk in our breakout session, that our classes are very, very geared towards those that are already working and want to continue the program, or continue to get a degree in a master's in management. So the idea is that we have a very friendly program for these people, and we're already have everything ready pretty much for our fall semester. Next slide, please. And so some of the requirements for it, we have 30 units for requirements. We have 8 basically core classes. These are in engineering management and the like. Others include human factors. We also have some systems program examples. And you'll notice we also have some core electives, but we'll talk more about that when we get into our breakout room. And finally, after that, we have a master's thesis that we ask of all our students. Basically, we have 1 to 2 students that come in with a problem. Usually these tend to be from their actual work environment. If not, we do help them find program themes for their thesis, but usually they're bringing them in from their work. Next slide, please. And I think you've seen many of these already about mission requirements. We do require a BS in engineering technology from an accredited program. We also look for a 3.0, although we do have some exemptions to these. And as others have said, GRE has been waived for the fall, etc. Next slide, please. Our other program, which is newer, is actually in systems engineering. And again, we do often have people from other programs coming in, so we're very flexible about how we allow these students in. The idea is that we're trying to teach them more about industrial processes. For example, I myself happen to come from a computer science background, and I went into industrial engineering simply because I learned a lot about the business of doing business as an engineer. Next slide, please. So in terms of the systems engineering, we look more at complex systems. So the idea is that we're looking across spectrum, talking about engineering management, how systems work, how they influence actual production lines, innovation, leadership, sustainability, and also organizational change. So a lot of times what we deal with as systems engineers is how to make sure we have a program that runs well. And so that's why we offer this program as well. You know, it's just like our engineering manager program, we're very friendly with those who are already in business, and we offer our classes after hours. That way they are able to come in and be able to do their full day of work, and hopefully also be able to study with us in the evenings. And also one thing I got to mention is that one of the main advantages of our program is we also tend to be very budget friendly for those that are trying to work out with their companies. And I believe that's next slide. I think a bit more. Okay, so our core requirements. Here we have our core requirements like this. We'll talk more about these in our breakout session, but you know, so we have 21 units of core SE requirements. Typically what will happen is that we'll have people that will come in, they will not have all the requirements, but we're able to get them up to speed relatively quickly. Next slide, please. And I will leave these since we already have talked about them before. And I believe that's it for industrial. And I hope I'll be pleased to see you in our breakout session later on. Thank you.
And next we have mechanical engineering.
Good morning, everyone. I would like to take this opportunity and welcome you to this info session about our graduate program. My name is Dr. Reza Lake. I'm an assistant professor in the mechanical engineering department. I'm coordinating graduate program of the department. My contact information is on the screen, and I will also host you in the breakout room after this session. Next slide, please. So the graduate program that we have in the mechanical engineering department is a Master of Science in Mechanical Engineering. Next slide. The objective of having this program is to prepare the next generation of students who are ready for more advanced work environment, who are independent problem solvers, and they can perform state-of-the-art engineering analysis. In this program, we have 3 areas of emphasis corresponding to mechanical engineering. So we have concentration on the thermal fluid, in which we go in depth in the areas of thermal fluid science, energy conversion, transport phenomena, and other biological and environmental systems. We also have an emphasis on solid mechanics. In this emphasis, we focus on strength of materials, vibration, nano and biomechanics, stress analysis, and system design. We also have established a new emphasis in our graduate program, which is the robotics. This program is already in place. We accept students. We have a curriculum in place that you can follow and receive a degree in that. In this emphasis, we focus on different aspects of robotics from mechanical perspective, more focus on control, robotics, motion planning, and biomedical robots. All of our programs is designed so that a full-time student can finish the program within 2 years. Like other departments, most of our classes are offered in the afternoon because we have many working professionals who join our program in addition to their full-time job. Next slide. So here's a quick review about our curriculum, and we can go more in depth in the breakout room. Again, a 30-semester unit is required to receive the degree. Depending on whether you want to do a thesis or a project, the number of courses is affected. So if you're doing a project, you're going to receive 3 credits for that. So you will need to take 27 units of graduate level work. If you're doing a thesis, which requires more extensive research, then the number of courses is dropped and you only need to take 24 units. Regardless of the thesis or project option, you can choose to conduct upright research with many of our faculty in the department. We have colleagues that do research in different areas, and they can be advisors of projects and theses. A GPA of more than 3 is required, and passing a graduation writing test is also required for graduation. Next slide. I guess I'm done.
All right, next up, the Office of Graduate Studies.
Good morning. My name is Salomon Oldak, and I represent the Office of Graduate Studies. This is the graduate office for all the graduate programs throughout the university. Next slide, please. So in normal times, we have an office in the Student Services building. And if you want to go to our office, you go to the orange counter and you can find us there. Right now, we're working on remote mode, just like everybody else. We have a total of 30 master's programs, and we have 1 EDD program. We have a total of 1,500 students throughout the university. And I just want to stress a point that was brought up before by several programs. First of all, for fall 2020, the deadline is July 1st, and the GRE is waived for all programs for fall 2020. And in addition to that, if you're an international student and you want to take the TOEFL, you can do Duolingo instead of the TOEFL to apply actually for any program at the university. Next slide first, please. So this is what our office does, and I'm going to go more in detail into that or answer any questions that you may have in the breakout room that we have specific for graduate studies. So we guide prospective and current graduate studies students. We support key steps in the graduation process. So for example, when you turn in your thesis, we are the ones that help you to do the thesis submission. We do some advisement. We promote student awareness and pursuit of graduate education and research. We are in the process of opening a graduate center for all graduate students in the university, and that is going to be hosted in the library as soon as we can do that. We review and process contracts, petitions, and oversee the submission for your project or thesis, and we implement and enforce policies in graduate student affairs. And I hope I can see you later.
Next, we have financial aid.
My name is Gary Byers. I'm the Interim Director of Financial Aid and Scholarships here at CPP. And as you've been able to see so far, we've got some really great graduate engineering programs here at Cal Poly. Our goal in the Financial Aid Office is to make sure that you receive the assistance you need to be able to pay for coming to Cal Poly Pomona for that. And to start with, it's a very reasonably priced institution for the quality of education that you receive for that. But we do offer assistance in various areas for that. We have a state university grant that's available to California residents. That's the only state or federal grant that's available to graduate students. We also have some scholarships that are geared particularly to graduate engineering students for that. We have 9 on the books right now, but we do have plenty of other scholarships that are more general in nature. So if for some reason you wanted to try for any of those, then a lot of those are just based on GPA and major as well for that. Next slide, please. Those are the rest of the scholarships there. And we also have an application available, which is at that address there. We also offer fellowships through our Human Resources Department for that, and have various opportunities for graduate students to do fellowships while they're attending the school here. Next slide. And then last resource, of course, is loans for that, but the federal Department of Education does have loans that are available to assist students with any balances that they may have after any other aid is being provided there to help meet your cost of attendance there, and we would certainly help you with completing those. And there's also a few other scholarship resources out there that are outside of CPP, but are great resources to use to find scholarships.
All right, well, thank you, everybody.